Welcome back, ladies and gentlemen. We're going to continue our look at the 2004 Pascal paper, and we're already up to question number 6. Hopefully you've given it a shot. If not, I invite you to pause the video and try it for yourself, and come back and then we can compare our answers together. Alright, question 16. If a squared plus 3b is equal to 33, where a and b are positive integers, what is the value of AB? Okay. So when I see questions like this, sometimes I think, well, maybe I can't get A and I can't get B by themselves, but maybe there's some way I can work out what A times B is. Often that's the case if I've got a bunch of equations, and then maybe I can multiply this equation and add twice this equation to the result, and somehow everything all falls away, and we get AB left on its own. Okay? But we only have one equation here. And we're talking about small numbers. I mean, it's 3 times B, and the answer is 33. So something we could do is make a chart of values, all possible A's and B's. But what I don't think we can do is just do some magic and then AB pops out. I think we will be able to isolate what A and B actually are. Okay? So the first step that I'm going to do is I'm going to write down this equation in my notepad. Notice, for example, if you wanted to make a chart, the A value has to be somewhere between 1 to 25. A can't be more than 6, because then it would be 36 plus 3 times some positive integer. There's no way that's going to be 33. So you can absolutely make a chart that way. Okay? And that won't take you very long. You do 33 minus 1, is that a multiple of 3? No. 33 minus 4, is that a multiple of 3? Because what we'd have to do is we'd say, we'd have a little chart. What's A squared, and so 33 minus A squared should be equal to 3B. So we want to ask, is this even a multiple of 3? And then we divide it and get B. So you do 1 squared, 33 minus 1 is 32. That's not a multiple of 3. 2, 4, 33 minus 4 is 29. That's not a multiple of 3. Okay? So you could absolutely keep doing that. But this multiple of 3 actually keeps popping up. So there's another way we could do this question. Let's rearrange this equation. And the chart would work. If the chart was your first instinct, great. It's a very short chart. It's only got 5 rows. It's going to be very quick to get. I'm just showing you another way to do it too, in case your mind works this way, or in case you want your mind to start trying to work this way. Seeing how these things happen and what we can do about it can help train us for the future. So I notice both of these are multiples of 3. 11 minus B. Well, if we've got a multiple of 3 on the right-hand side, that must mean A squared is a multiple of 3. And there's only one square in this list that is a multiple of 3. So A squared, it could be 9, or it could be 36, but, or it could be, what's the next one, 81. But no, it doesn't work like that. These are too big. It can only be 9. So A has to be 3, and A squared has to be 9. So now we've got 9 is equal to 3 times 11 minus B. Divide by 3 on both sides. 3 is 11 minus B. Pretty quick to see B is 8. What did they ask us for in the question? They asked us for AB. That's going to be 3 times 8. A final answer of 24. You could have approached it with the chart or with this deduction. Either way, frankly, the chart might even be faster. But we get our answer of B. And it's a good answer. We'll flip the page in anticipation of our next question, and that will be question number 17. So hopefully you'll join me for that in the next video.